Hey everyone, welcome back to the channel. Today we are solving one SQL problem that every e-commerce company deals with almost every day. And that's the problem of the abandoned cart. And today we will learn how SQL left join finds the revenue that company might be losing every day. So the scenario here is that we have two table. One is cart table, items people have added in their cart but not processed for payment. And then there is a second table which is purchase table, which has basically the items actually bought. And the problem we have is that we have to find the users who added a high value item to their cart but never finished the checkout. We might be interested to mail them, we might be interested to provide certain discount to those consumer, but before that we need to identify such users who have items added in their cart. So this is a classic business problem, and guys, you should also understand that SQL is basically to solve certain problem, and that problem is mostly with any business. Today we are discussing about e-commerce business, but it can be in any sector. So this is the problem we are having, that users had added high value items to their cart but never completed checkout. We want to identify these users to calculate the lost revenue and email them a 10% discount code to recover the sale. So this is the statistics that I have taken from Google, that 70% average cart abandonment rate, and this is the lost revenue annually worldwide because consumer have not processed for payment and final checkout. And if we use certain marketing strategy by providing certain discount or notifying all those users, then we can recover at least 15% of the lost cart, which otherwise is just lying in the cart. In any e-commerce company, this is basically the user journey. First of all, you browse the items, then you add them into the cart, then you check out, and then payment, and then of course thank you, and you get the notification that your shipment is ready to be delivered. But most of the consumer don't proceed before for after this step. And today we are going to solve this problem using SQL. This is the table structure and sample data. So as I mentioned during first slide, that there are two tables. One is carts and second table purchase. This carts table is basically where every item a user adds is recorded, and in purchase table where complete checkouts are stored. So there are four columns in cart table: cart ID, user ID, item name, and price. And in purchase table, we are having purchase ID, cart ID, user ID, and the time. So if you just see these two tables, you can see that there are 3, 4, and 6. These cart IDs, they are not present in the purchase table. That means these are case of our abandoned cart. And if you see the potential revenue, that compiles to $1,737 for this particular scenario, which is huge. This is just a sample data, but using this we are just basically trying to understand that we can use SQL to solve some business problem. And we will use left join to solve this problem. And after left join, we can find that there are these are the user IDs or cart IDs which are not having any a corresponding purchase ID, because they are not coming in the purchase table. That means these are abandoned, present as a abandoned cart. So here we will use left join. And also you should understand that when we in the final output, we will only be interested in these rows which are highlighted in red color. So it will be like an anti-join. So why left join plus is null is a case of anti-join. We have already discussed about anti-join in one of our previous video. You can also refer to that. But again, you should understand why we are using anti-join here and why it is called anti-join. because left join keeps everyone from the left table, even people with no match on the right. Now when there is match, the right side column become null. So in case of left join, basically all the records from the left tables are recorded, and then the corresponding values from the right table is presented here. And there are no matching columns in the right table for these three items: USB, MacBook, smartwatch. So there is a null coming here, and we will use left join plus is null. So that's a basically anti join. So there is a small difference between normal join and anti-join. Normal joins is basically something we say that give me the row that matches, whereas in anti-join it gives me row that do not matches. So that's why we say it anti-join. And this will be the SQL query that we will be writing and executing in the SQL Management Studio. So there are two tables, carts and purchase. So we are interested to find cart ID, user ID, item name, item price, and then we also want in the output that what will be the discount amount, and we will multiply that with 0.10. Then we will see what will be the final discounted price, which can be obtained after subtracting it from the actual price or the original price. And this will be alias as discounted price. Like we have alias this as discounted amount from cart C, which is our main table, join left join. Then this is our purchase table, which we have given alias as P. And this is own keyword. Basically we are joining these two tables on cart id, so the match will be on the cart id. That's why we are using c.cart id equal to p.cart id. And this is a classic case of anti join where p.purchase id is null. So basically I'm interested to find only those output after this join which are having purchase id as null, because only those are the items which are not coming in the purchase table. And when we will execute this query, this will be the output. Basically when we execute this query, this will be the output. So with this we can have answers like who to email, how much they almost spent, and what discount we can offer. So this is the item price, and this is the discount amount, and this is the final discounted price. So what this is the action that that the concerned department or team can take, that they can send user ID, these user IDs a mail that your item is waiting. They can be provided certain user code or discount code for some discount. How it works, so we can also have a elaborate explanation that how that a particular query is working. We are using left join cart plus purchase. Left join keeps all the 6 cart rows. For carts with no matching purchase, every purchase column returns null, as I've also shown you in previous slide. And this is the foundation of anti join, where p dot purchase id is null. It filters to keep only rows where no purchase was found, and this is the anti-join filter. And c dot item price is greater than or equal to 50. This is just to illustrate that most of the time we provide discount mostly for high value item. So this is an illustration example. This value can be anything, but this is how we can use this query. Then we will calculate the discount amount, order by item price, DESC, because we want to sort the highest value first, so the marketing team can prioritize the item accordingly, because highest revenue impact first. So these are the some key takeaways we can have from this and from this presentation for this example, that left join is the anti-join engine. It keeps all left table rows, putting null where no right match exists. And this filter where right table dot id is null is the magic filter. It isolates exactly the row with no matches. And similarly you can use a select statement, and you can also use filter like that the item value should be greater than certain amount, so that you are only prioritizing high value items. And this particular scenario can be extended to many other pattern or different problems. For example, a newsletter subscriber who never opened your email. Then again, there are registered users who never logged in. There can be coupons which have been issued by the company but they were never used. Similarly, there can be cases where there are support ticket raised but no response. So accordingly, this type of concept can be used for different application. Now we will see this in SQL Management Studio. So I have already created these two tables. Select star from cards. If you execute this, you will get the card table. And similarly, if you select star from purchases, so these are the two tables that we are having. Card table, as I already explained to you, that it is having all the items user added that is recorded in this particular table, and in purchase table we have records where the complete checkouts are stored. So now let's write that query that I was just showing to you. So you can see that these are the cart ID, user ID, item name, and item price which are present in cart table. So I want all these also in my final output. So I will write select cart ID, comma, user ID, comma, item name, item price, from cards C. So I'm giving this alias. So in joins it is a very good practice that you always use alias. Now I can write here C dot cart ID, similarly C dot user ID. So here it will be like this. Similarly for item name, C dot item name, C dot item price. Also, as I was showing to you, that we are also interested to see how much will be the discounted amount. Item price multiplied with 0.1, and this can be alias as discount amount. Similarly, I was also interested to see what will be the final price after the discount. So you can use this formula to write that minus C dot item price multiplied with 0.1. So this can be aliased as discounted price. So basically we want these 1 2 3 4 5 6. So these are 6 columns that we want in our final output from cart. And now we will apply left join here. Left join. Left join is purchase. You can check the spelling because that needs to be exactly the same. Purchases P, and own keyword C dot cart underscore ID equals P dot cart underscore ID. And as I mentioned that we can also, let me first write this, where P dot purchase underscore ID is null, because we are not interested to see those users who have already make some purchase. We are only interested who have added the items in the cart but have not proceeded beyond that step, beyond that stage. And also, as I mentioned that we can use this application to mainly filter the items which are having high value items. So just for illustration, we can also write this, where item price is greater than 50, just for illustration. It can be anything in practical. And then we will order by it, c dot item price DESC, because we want that high value items should come first, so that marketing team can prioritize that, because high value items will impact most on the revenue. So this is our query that I have written. Let's try to run this query. And if you run this query, it should show you the desired output. I think there is certain issue in this. Let's check again. Yes, I think that's card ID. Okay, it's cart. I think now it's correct. Everything is correct. So make it a habit that whenever you are writing query, cross check, because here the spelling needs to be exactly as per the values in the original table. Yes, yes. So if you execute this query now, you will get the desired output. You can see these are three cart IDs and these are three user IDs, where there are three item names, and these are the item price, discounted amount, discounted prices. So that's basically all about this abandoned cart problem. I hope you find this problem a useful problem. And also with this problem, I try to explain you the application of SQL in real life applications, because SQL is all about solving some problem. So if you have any doubt with regards to this question, this problem, feel free to ask in the comment section. We will meet you in the next video with new application of SQL. Thank you.